So now what we're going to do is we're going to see a new concept here, that of a reference angle. Reference angles are actually going to help us evaluate trig functions easily at any angle. As you'll see, it does involve what we learned already from right triangle trigonometry, as you'll see as well. Now first, let me get this definition out of the way. A quadrantal angle, that's an angle when in standard position, the terminal side is either on the x or the y axis. So in other words, it's an angle that is either 0 degrees, 90 degrees, 180 degrees, 270 degrees, or it's coterminal with any of those angles. Those angles are not going to have reference angles, mostly because we don't need a reference angle for those. It's very easy to figure out what the trig functions are at those angles. Mostly because we know what the point P is going to be from the definition. For most other angles, that point P is not going to be so obvious. Okay, so now we're ready to talk about reference angles. All right, so let's suppose theta is an angle that's non-quadrantal. In other words, it's not any of these four angles or any angle coterminal with them. So the angle's not coterminal with either of these, with any of these. By definition, the reference angle, it's the acute angle the terminal side of theta makes with the x-axis. Keep in mind, we're assuming theta also is in standard position. So we're assuming theta is in standard position. I know the definition doesn't really say it, but for our purposes, we can assume that though. All right, now, let me draw some examples of this to make it clear. Okay, so again, here's x and here's y. So let's suppose theta looked like this. That's the initial side. Let's suppose it was in quadrant 2. All right? Now, theta looks like this. So here's theta. All right, well then the reference angle, again, it's acute, and it's the acute angle the terminal side makes with the x-axis. So that's going to look like this. So this is theta sub capital R. Okay? That's what theta sub capital R is. It's that angle. Let me do another example. That was in quadrant 2. Let me draw it in quadrant 3. So let's suppose theta is now here, like so. Okay? Okay, well, if that is theta, theta sub R, again, it's the angle the terminal side makes of theta, makes with the x-axis. It's acute, so that's got to be this angle, like so. I can understand how it's tempting to say, what about this angle here? Why can't that be? Why can't this angle be theta sub R? Well, the problem is this angle is bigger than 90 degrees. So it can't be acute. And by definition, an acute angle, a reference angle has to be acute. Okay, now, let me just fix that. Good. Now, let me just draw one more example, but let me just fix this. All right, let me draw now what happens in quadrant. Well, let me draw two more, actually. What about quadrant 4 and quadrant 1? Well, quadrant 1 is pretty easy. In fact, let me do quadrant 4 now. So that's here. So this is what theta looks like. Okay, well, what's the reference angle going to be? Again, it has to be acute, and it's the angle the terminal side makes with the x-axis. So that's going to be this angle. Finally, let's suppose theta was in quadrant 1. It just makes this right. Okay. So let's say, again, we're in standard position. So theta now is in quadrant 1. Like so. Okay? So this is what theta is. Well, if the reference angle is the angle the terminal side makes with the x-axis and it's acute, well, it has to be this angle, theta, the same, it has to be the angle theta itself. Mostly because theta in this case is acute. So in this case, theta sub r, in this case, the reference angle is theta itself. Okay? And again, as you'll see, well, you'll see that theta sub r, the reference angle, can be used to evaluate the trig functions at any theta, and we don't allow theta here to be quadrantal, okay? Because we know how to get the trig functions at those angles. Okay, there actually are formulas to figure out what the reference angle is. And we already said that if the angle theta is in quadrant 1, then theta is its own reference angle. I just drew that before, but for fun I'll draw it again. Here's x and here's y. So let's say theta was here, okay? Well, again, here theta is itself acute. The reference angle has to be acute, and it's the angle the terminal side makes with the x-axis. So theta, as you can see, theta and theta sub r equal each other in this case. What about in the other quadrant? Let's say, excuse me, wrong color. Let's say this one. So let's say now it's in quadrant 2. Y and x, like so. So here's this. Okay, so this is now theta. Well, how do we get theta sub r? Well, we already said this is theta sub r. But if you remember, this angle is 180 degrees. Well, how could you get theta sub r then? So, let's see. Well, you might be able to, hopefully you can see visually that you can take 180 degrees and just subtract theta. What you're going to be left with is this. It's almost like you're taking all of this and then you're throwing this part away. So you're going to be left with this. And of course, if theta happens to be in radians, this would be the same as pi minus theta. Remember, pi is the same as 180 degrees. Okay, what about quadrant 3? Well, let's see. It's really the same idea. Well, it's similar, I should say. So theta's down here now. Okay, well, as I said just shortly before, theta sub r is this. So again, this being 180 degrees, how can you recover this angle here? Well, you could take the entire angle, theta, right, all this, and throw away, that is, subtract 180 degrees. You'll be left with theta sub r. So in this case, in other words, we have theta minus 180 degrees. So this will equal theta sub r. Let me just go back up here and write this, just to make it easier. And as before, if theta is in radians, then you have this. Now, for quadrant 4, see, I don't know if I have room. Well, let me do this. Let me do it down here. Hopefully you'll be able to see it. Though actually, I have the formulas here. But let me draw it below here then, because I really want you to see what's happening visually. I mean, what's above, these are the formulas, and I'm trying to show you why they're true. But you really don't have to memorize them. It's really just visualizing it. So this is theta. Let's suppose now theta is down here. Well then, theta sub r, as we saw already, is this. Okay, so how can you recover theta sub r from theta? Well, as we said already, 0 degrees, right? That's coterminal with 360 degrees. So what we can do is do 360 degrees minus theta to get theta r, Or again, in radians, that's the same as 2 pi minus theta. But again, you really don't have to memorize the formulas. Just draw the angle and you should be able to visualize it. So, of course, that's assuming you know what the reference angle, what the definition of it is.